Is it on live? Let me see. Okay. Okay, hello, hello. Can you hear me? Okay, so it's time for a weekly Houdini tutorial live stream. And this is 130th episode. And the topic for today is to create a kind of a stylized procedural smoking simulations made in Houdini. Right. So that's what I'm gonna do today. Let me also share this too. To the okay. So hopefully someone's watching. I'm just gonna start it. Okay, so today, well, I don't really smoke myself. I don't really like it, but I do like the effect how smokes comes out of a tobacco. But I mean, there are several ways you could simulate smokings. Obviously, you can just use DOPs for that with volumes, but that's too straightforward. I didn't want to use that, so in this live stream, I'm just going to use a procedural process, just using a bunch of curves to create a trail for the smoking and use that to animate kind of a smoke-like animations, just like you might see in some animations. So things that I'm gonna create, it's more like a stylized deformed smoke system, right? Which is gonna be procedural, so you can just loop it from end to start frame, right? That's what I'm gonna do, right? So let's do this from scratch as always. Alright, so let me just go over the process that I'm going to follow for this tutorial. First, I'm going to create a bunch of curves which is going to be used as a trail for the smoke. I'm gonna create a bunch of curves like this, which is going to be a base curve. It goes from the starting point to the end point. And what I'm gonna do within these multiple number of curves, I'm going to create a deformed curve. For example, if this is number 0, 1, and 2, I'm going to move or deform the curve itself to become something like this, and then goes to this one, then go back to the 0 within a certain frame. So that the trail itself just moves, looping with the loop, and also you also going to animate on top of this curve as well as a smoke trail. So there are two animations happening in one setup. So that's just the basic idea for this one. And in order to create the curve, I'm going to use a node like Detangle node, which can be used to have a space between the self curve. You can use to do the self collision detection, so the curve won't touch to each other within the curve itself. So using that, you could create kind of a trail-like curve, one continuous curve which doesn't touch to each other within one curve, within one space. So that's my plan. Alright, so let's do this, shall we? Okay, so going to do this from scratch as always. Okay, so first thing first, I am going to create a base curve for the trailing. And in order to make that, I'm okay just making it as a random trail. I mean, it's not going to be physically correct at all. It's just gonna be some stylized, looks like smoking simulations. So nothing physically correct, but that's my plan for today. So I'm gonna start by creating a box and convert it into a volume. Then create a bunch of points inside. This volume to scatter multiple number of points. Okay. And I'm going to use these points to create a randomly connected curve network first. And that's going to be the base for the trailing curve. Okay. So decide how many points you need. Then you could use a add node. Okay. And make it connected. Right, like this. Now this might be a too much of a point, but let's try with this for now. Okay, now that I have created a bunch of connections between points, I'm going to make it smoothen out of this straight polylines. By using something like resample. Okay. And I'm gonna fix this to 0.1 for now, which is going to create a bunch of points on top of these polyline, and then I'm going to change the tree polygon as to subdivide. So it's gonna smoothen out the curve a little bit. And additionally, I am also going to give some smooth node. Might not necessary, but just as a little touch to have more smoothness. Okay. Okay, now the problem is at this point is that some of the points are too close to each other within this curve. For example, these are more like intersecting to each other. The distance between the self curve is a bit too close. So I want to avoid that somehow to make the final trail a bit more cleaner to see. I mean, it's not really necessary, but I want it to have some space between the curve. So in order to do that, I am going to use a node called Detangle node. which is also used in physics simulations like in Vellum to avoid having collisions between curves. Okay, so if you just connect it, now it gives you an error because I'm missing these previous positions. So before doing the collision detection, you need to have the original point positions stored in some attributes to use this. So I'm going to create a REST node, and this will copy the point position to a REST attribute. So I'm going to use the previous position as REST attribute as a previous positions. Okay. And for the default thickness, this will be the collision detection distance, and higher the distance is, you have more repel forces. Now, since I have this resample node with a length being chosen here, I could relate this threshold value for the detangle with this one. So I'm gonna copy this value from the resample node to the detangle default thickness and multiply by 0.5, since it's asking for the thickness, meaning it's the radius of the curve. Right. So this is the result of the first batch of this detangle node, but in order to have the best result, you need to continuously doing this recursively over and over again in order to get the best result. The first batch just gives you just a small change if you compare with the previous one and the updated one. So and I realized the point number is a bit too high for now, so let's make it something like 25. Yeah, this will be easy to see. Okay, now going back. So this was the previous position, this was the new positions, and I want to update several more times for this detangle node recursively. And to do that, I'm going to use a for each number. Change this to fetch feedback, and this one to fetch feedback each iteration, so that it will change the loop to feedback loop. And I am going to set this node inside the loop. Okay. Now, by doing this, you could bring up the result of the last iterations to the next iterations. And by increasing the number of iterations, you can see the curves being updated slowly by having a distance between the curve more and more. Okay, now the problem is you could also see that the curve is becoming a bit jaggy here. So I might also want to introduce some smoothness inside the loop as well. So let's do that. I'm going to give another smooth node. Right. Now the change become a bit drastic here. So if you increase the iterations, you can see the curve is being smoothed out, as well as taking the distance between the curve. And things are getting a little bit better. If you don't like the smoothness, then you can also remove it by changing the strength. But I'm gonna keep it as 10. Right. Okay, and so far so good. Hello. Hello, thanks for coming and tuning. Can you explain the detangle node, please? Okay. So detangle node is used to give a space between calculate the collisions between the curve, between the input curve. Now I'm only inputting one curve, so it's trying to detect the self intersections if it is a curve. And if the point distance on a curve is too close by looking at this default thickness, and if it's less than the default thickness, then we'll try to go to the it will try to take a distance between 2 points. So currently the distance is a bit far, but if you make this to the first iterations, and for example, let's say if the distance between this point and this point is more than more than 0.05, which means these points are too close. As a result, the detangle node try to make this point far away from this point and this point far away from this point. So going to this direction for this point going to this direction. And as a result, you're having all those points given some distance to each other. Now that also counts for the points on the neighbor points, so you have to be careful this value become more than this distance. If you make this distance default thickness more than this distance, then you're gonna have some weird crashing or weird like jagginess starting to happen. Like for example, if you make this multiply by 2, then and since I'm using the resample node to make it 0.1, it's not gonna end well. So make sure how much distance you have on the neighbor points. It has to be less than that. Okay. So far I think that's good. Now, since I am making a smoke simulations I need to have a starting point created. Which in this case I want to create the starting point to maybe on where the x and z value is equal to 0 and somewhere underneath this whole curve. Maybe somewhere around here and so on. And maybe probably it's better if you could control where the starting point could be. Okay. Now I guess it also depends on the starting box size. So let's start from this box size here, which its radius is 0.5. By looking at the uniform scale, you can copy this value and you could set the initial starting point to be minus 0.5 for the y directions and 0 for x and z. So and I also need to define, I also need to create those first points somewhere in this setup so that it will smoothly connect with the starting point with these curve. So I am guessing I could do that somewhere inside here. Every time I do the detangle self-collision detection, I could add a or I could move the first few points to the center, then fix that point position to that point. Okay, and let's try that out. Okay, so I'm going to create a point wrangle in between the detangle node and smooth And I'm going to select few points. If I show up the numbers of these points on a curve, the starting point for this curve is where? Here. So what I want to do is to move several points, could be just 0, 0, 1 or 0, 1, 2 on top of these line where the x and z value is equal to 0, starting from the bottom of the cube size. So let's have the cube size first. By copying the value that I have copied from the box, which is the uniform scale, and I'm gonna multiply by 0.5, since this is the diameter and this is the radius. Okay, now and I'm also going to choose how many points that I'm going to use to align within this line. So let's say if pt num is less than some specific number of points, and let's make a parameter like if like 2, so if it's less than 2, then I'm going to move the point to where the x and z is equal to 0, and for the y you could start from a negative cube size and add it, or add it by the point number multiplied by some distance, I guess. And for that, maybe I could make the end point to be here, coming here at the 0, 0, 0. So what I could do is to use something like fit function to convert the pt number, which is go from 0 to chi number -1 to, and if the point number is equal to 0, you want to use the negative cube size, and if it's equal to this value, the end value, you want to make it 0. Okay. Now you see that point 0 and 1 came on this straight line, and if you increase the point number, you start to see more points being placed on this line. Now currently I still see these two not too smooth curve connections here, but by having smoothness after that, you can smooth it out. And since I have several loop iterations, it's gonna smoothen out more and more within the loop, and now it becomes smoothly connected to the starting point. Alright, looks good. Okay, alright, and I might also want to control this distance. I mean, I might want to move this a bit upward or downward a little bit. Let's also introduce some offset to the y directions by adding some additional offset value. Okay, and I want to make it negative as well, so let's say -1 to 1 as a range. Okay, and if I change this, you can see I'm changing the offset. The lengths are how far it starts from the bottom. Okay, that's good so far. Now this is so this is a curve for one batch. What I want to make is multiple number of this kind of curve with different shape, so that I can move between those different number of curves, different shapes of curves, to have an interesting animation between the curve, changing the curve shape itself, but still as much as possible avoiding the curve intersection as much as possible. I mean, if you use the curve animations, you eventually are going to have a curve intersections at some point, but at least within this, some of the batch will is having this collision detection, so better than nothing. Okay, so things that I want to do next is to create a multiple number of curves with different point positions. So let's do that, and I can do that by repeating this process multiple number of times. I'm just gonna add another for each loop here, bring it inside here, connect it here. Okay, now in order to change the shape, you need to have some randomness somewhere, and one of the place you could set the randomness is for the point seed, I mean the scatter node, inside this global seed. By changing this, you can change the shape itself actually. So by just changing this, I think that's enough to change the shape. And since all the rest of the process can be used, it's still avoiding self collisions because of these rules here. So let's try just changing the global seed for each iterations, and you can do that by accessing to the detail attribute of this for each count, in this case using something like iterations or I value. I'm going to use iterations for this one. So going back here, I'm going to access that value, access into the detail attribute for each count, for each count 2, iteration, and it's multiplied by some value to make a bit more randomish, then starting with some random numbers. It's not really necessary, but just to make it a bit more randomness. Okay, so for I think this will create random values for each loop iterations, and as a result you should be able to see multiple number of curves with different shapes like this. And if you decrease the number of total loop, so this is where the loop is equal to 1 and 2, 3, 4, 5, so on. Okay, so let's keep it like something like 5 or 4. And you can also go back to these process, changing the Y offset, everything is changing the same. That. Alright. Okay, that's good. Now, the next thing I would like to do is to create a tweened animation or tweened curve between those multiple number of curves. If you have 4 curves, I want to make a in-between curve between those curves. So for example, if I have one curve like this, one curve like this, one curve like that, and one curve like that, what I make is to, and if I want to go from this curve to this curve, this curve, this curve, go to this curve, I want to tween the curve so that it will gradually change the shape to the next curve, and continue back to the original positions, original curve, so that you can loop it within these curves. Okay, so that's my plan. And to do that, one of the way I could think of is to create a disk between the points for each curve, meaning I am going to create a disk for the rotation. For example, if you have one curve, two curve, three curve, and four curve, I'm going to connect all the points on same U value, U positions, something like that, something like this. If it's sharing this position as a when U equals to 0.5, then I'm going to connect something like that, something like that, and something like that. Okay. And having those section curves, you can now pick the same U value, the U positions on a curve, and connect that position to make an one curve. And by moving this U value on each section curve, you can actually move this curve, which is tweening between the multiple number of curves. Okay. So that's my plan. And I guess that's the simple way to achieve what I wanted to create. Okay, so let's do that. And in order to do that, it's a good idea to have same number of points for each curve, I think. So let's do that. And to do that, what I could do is to first create a resample node to have a same number of points for each curve. So uncheck maximum segment length and instead use maximum segment, which will enable you to choose how many points you want to have for each curve. So it's set to several numbers, which also becomes the final resolutions of the curve, but I'm gonna make it as 100 for now. You might need more if it's more complex, so I might need to be able to change this based on the current resolutions. So in those cases, I could check the current point number for each primitive by accessing to those point numbers by promoting that value to each primitive. Using primitive wrangle, going to promote the point numbers by accessing to the prim points at each primitive. And this will give you a point array, and by getting the length of this array, you can get the size, how many points you have on each primitive. And if you check it, so these are the value that you get for each curve. So in this case, I think it's a good idea to have the maximum point number and use that to do the resampling. Yeah, so let's do that. And in order to get the maximum value, I'm going to use the attribute promote to promote this primitive attribute to a detail. The name is pts_num, and yeah, I can just delete the original because I don't need it anymore. And looking at the detail attribute, and I need to change this to a maximum so that I can get the maximum point number for a primitive. Then I can access to that value from the detail from your own node. So access to a detail by using op input, looking at yourself. The attribute name is pts_num 0. Okay, it's not getting it. Okay, so pts_num. Okay, I might be missing something. Okay, spell mistake. pts_num. Alright, so this is the value that I get. Okay, now each primitive should be having same number of points. Now it will be easier for us to create a connecting curve between all those points. Okay, so how do we do that? I'm guessing setting a same attribute for each point on each primitive and using that attribute to create the curve is a easy idea. So I'll do that by accessing to a current index of the point for each primitive. So I'm gonna use a point wrangle, and I'm gonna call this a pt index. So I cannot just use pt number because this doesn't gives you a number or index number per primitive. So instead I need to somehow find out the index number for each point on each primitive. So to do that, first I'm going to look for the primitive number which this point belongs to. You can get that by using point prims for the current point number. Then this gives you an array. Now I'm sure that each point only has one primitive assigned to it, so I can just get the first one like that. Now I can get multiple number of points which belongs to the primitive now using prim points by using the primitive number that I found, the primitive number which this point belongs to. Then I can find all the points within this primitive. And now finally I can get the index number in which positions this point belongs to this primitive by finding the index number by using the find function. And finally I can promote this as an attribute. Okay, let's check that. I am going to create a marker for the index. Right, so I'm gonna name it index. Make it a bit larger. So the starting point always starts from 0, 1, 2, 3, and I think it's going well. Yeah, I think it looks correct. So that's the index number, and what I want to do is to create a connecting curve which connecting all the same index number. Like if it's 6, then want to connect all those 6 with the same curve, and so on. If it's on 0, then it looks like a point, but you actually have a curve here, there, a transparent curve. Okay, so that's what I want to do. Let's do that. Okay, and before doing that, I don't need the original curve anymore. I just need the points, so I can just delete those, delete the primitive. To connect lines points together, can you use add with connect every x points, which would be number points? I guess you could actually do that, yeah. Actually, that might be easier. Can you try this? Vertex primitive index. Vertex primitive index, prim index. Oh. Would that be... I think I never used that function myself. Let me check how that works. Vertex prim index. Okay, so to convert the linear index to a primitive number and primitive... I see, I see. Okay, so you could actually use the vertex number. Maybe that's might be better than point number. Yeah, you could actually use this, I guess. Yeah, thank you. And for the add node with connect every x points, I'll try that later. First, let me just delete this one, keeping the points. Now, the things that I wanted to try initially is using add node, going to polygon by group, change this to by attribute, then choose index. Okay, and make it closed. Okay, so let's try the other process, like the comment suggested, like the Alin suggested. So in this case, we're suggesting using skip. Now connect every or skip every endpoint. Yeah. Group of endpoints. And if you know how many points to connect, maybe not. Maybe this is not the one. I guess this one, skip. And you need to know how many, I guess you need to know how many primitives that I had. So I had 4. So if I skip it by 4, does it work? Hopefully this will give you the same result. Not sure if it's doing. Maybe not. Maybe I'm doing something wrong here. Skip every one endpoint, that will be 120. I see. Yeah, I realize that I have to skip every primitive number points. So that is this one, I guess. So let's copy this. And change this to here. Something weird. Well, not sure if it's working. Might not. If I add it by 1, maybe that's not the case. Oh, it worked, I guess. Oh yeah. Oh yeah. So I need I needed to add by 1. Okay, so yeah, this is easier, but you need to wrap up your mind a little bit. In this case, you don't need this index value, I guess. Let's make a switch node so that I can make it as a log. Make it like this. Oop. So let's say this is the first choice, this is the second choice, which in this case you don't need the index value. Yeah. Alright. You don't need the delete either. Ah, really? Oh, that's true. Oh. You can do key points only on the add first half. I see. First half. You can do key points only on the add, the first half. This one. Oh, thank you. I think I never used that option. Okay, that's good. Thank you. Alright, this is much simpler. Let's go this way. Thank you. Alright. In terms of the vertex prim index, let me see how I could use that. So you need to have a linear index, so I guess you need to use a vertex wrangle for that one. And let me see. Let me first check what kind of value I get out of this function. Vertex prim index 0. Right. I see. Yeah, you can actually use this for sure. And I wonder if I could use this on points as well. Well, seems like you could actually use this. Nice. Alright, so seems like I can just use this as well. I mean, it's much simpler. Okay, so in this case, I can do it this way. Cool. Thank you. You have now 3 options. And these 2 are much better. Yes. Thank you. Alright, so let's go. Now that I have these curves, right now it's a bit too pointy, so let's make it smooth for these curve that I have just created. I'm gonna do that by using again a resample node. Right, then let's see, going to make the treat polygon as to interpolated curve, And I probably need a bunch more points, so I'm gonna change this length to something like 0.02. Yep. Oh, you have a bunch of smoother curve. It's better. Now, in the end, I would just want to treat these as a path where the point goes, so I don't need the primitive. I mean, I don't need the faces. So let's just delete the face and just get the curve. I'm going to use a primitive properties just to get the curve out of the primitive. Go into the face hall and unroll the U value with the shared points. Yep. Now that looks noisy, but these are the path. These are the trail of each section. Now after having this one, you could actually get the curve, the single curve out of this path with maybe an animation. Based on the frame, you could choose a specific curve on specific U value. Okay, so let's do that. Well, I am going to use first I'm going to get the points on each curve by using primitive wrangle. For each primitive, get the point on U. So to get the point position on specific U value, which is from 0 to 1, 0 is the starting point and 1 is the end point of the curve, you could use prim_uv for that, accessing to a p attribute for each primitive. You can access to for now I'm just going to make it parameter so that I can see which point is being getting, and create UV value by just changing the U value. Okay, so this will be the U value here to get the point position on the curve, on each curve. Then add that point as a new point. And the rest of the primitive that I have right now, it's not necessary anymore, so let's just remove it. Okay, this is the one curve at specific X position. And I can promote this X as a slider, and by changing this value I can see it's changing its shape, going from starting point to the end point and go back to the original. Okay, let's try to connect these points together by adding another add node, polygon by group. Alright, then also sliding. Okay, and let's try to make it as animation by using a frame value. Okay, now I did got the animation, but I did got those transformations, but the problem is some of the curves are a bit jaggy, so I also want to make it smoothen out for sure. So let's do that. First thing I'm gonna do, I mean, there are several ways you could do that, but what I would do in here, I'm going to use the resample node again with some lengths like 0.25 or something with subdivisions to have a little bit of smoothness to the current curve, and then add a additional smoothness to have a bit more smoothness. Yeah. And you could actually increase this if you want. I mean, it's not really necessary, but yeah, just a small change. Now if I play it, a bit more smoother. Okay, well this is just to make, the reason why I did this is just that I wanted to make some random path, but also loops within the frame. So the process could be anyway. It's just the process that I came up with for this setup. Okay, so let's say I'm okay with this. Next, next thing I would like to do is to have some offset, the time offset to this curve, so that as an example I shown previously, like this one, you see it's having a single trail, but in the end you're having some multiple number of lines running on a curve like that, like these, like these. So in order to achieve this, what I want to do is to offset the single curve a little bit based on the time, meaning the result that I want is something like this. Offsetting the original curve by shifting the timeline a little bit to the front or to the back, so that as a result, since the curve itself is animating, you are getting some shift on a curve. Okay, and use those multiple number of curves to create the final animation. Might make more animation, the final animation, a bit interesting. Oh, so that's that's the purpose. So let's do that. What I'm gonna do is to shift this curve's timeline to forward or to the backward, then give some curve offset. Okay, and to do that you can use this time shift. Okay, and by adding to the current frame, by adding some additional frame, you can go forward to the future. If you subtract by some number, you can go back to the past result. And if this value goes to negative, then somewhere around here, then you can go back from the end frame. And if you go over the end frame, then you can go back to the first frame. I mean, if it's like 245, then you can go back to 5. Okay, so let's do that. And in terms of the value, how this value being determined, I'm gonna make it random. I'm just gonna decide how many offset that I want as a number of curves. Then for the total, for each curve, the offset value, I'm gonna make it random by just setting the maximum offset, maximum timeline, time value, time shift value, time offset value, whatever. Okay, so I'm gonna use for each number again for that purpose, because you can only use this on for loop if you want to use it multiple times. Let's make this starting from two loops or 3. Okay, and for the time shift, what I want to do is to add some random value to this current frame value, which could be positive or negative. I mean, I could just do the add value so that it never goes to negative value. That might be better, because if you go to negative, then you have to add additional conditions when the value is negative. So let's add some random values added to this time shift. So in order to do that, you probably need to get the random seed value for the randomness. So let's get that from this detail count for each count, which in this case, again, using this iteration value. So going back to here, let's say the maximum time shift value is like 20, and I'm gonna multiply it by some random value, which is in between 0 to 1. And you can use the expression like rand. Okay, and then access into a detail attribute from the, in this case for each count, 3 detail for each count. Count 3 iteration 0. Okay, and just in case, multiply this by some random value, additional random value. Now this will give you the value in between 0 to 1. Multiply by 20, you can get the value between 0 to 20. And that's probably you need to do. And let's make it as a float value here. And also, I guess I'm okay with the float frames for this one. Not sure. Then for the whole frame value, if it goes over 240, then you can go back to here. And since it starts from 1 to the end frame, what you want to do here is calculate the remains by the end frame and add it by 1 later. Yeah, so if it's 240, I guess, if it's 240, yeah, then you can go back to 1. Yeah, I think that makes sense. Let's see. Or you could also say it's +1. Either way is fine, but let's see if this works. Let's see. So going back, going outside a loop, you are now having multiple number of offset for this curve. The things that I want to check is if this goes from the end frame to the first frame, if it cleanly connect with the loop, with the end to first frame. Okay, it did. Yeah, I think it did. Let me check this again. Yeah, so there were no glitches, so I think that's fine. What if I add this by 1? Doesn't make any changes. Yeah, it looks good. I'm not sure if I see any glitches here. I did. What if I have not +1? Yeah, maybe this is better. Yeah. Okay, so you have now those curves being offsetted by times and being looping. as well. Now you could increase number of offset like that, and still working. Now you could also change this randomness to something like noise function, so that you could gradually change the offset value based on the frame value. Though the problem is, if you just use the noise value by itself, it's not continuous. It's not going to create a continuous loop from end to first frame, because you're changing the C value. So you need to somehow have the same seed value for the noise on the first and the end frame if you want to use the noise. But let's try that. Since it's gonna be a bit more organic rather than using rand. Okay, so instead of randomness, using noise, and forgot what was the input value for the noise function. Let me check. So noise function, so you need to provide x, y, and z value, and you get a float number as an output, right? So the first value, the x, could be same as the same value for the seed that I created for the randomness. And for the y, I could use some time-based value, which changes from, I don't know, 0 to 1 to maybe back to 0 again. Or 0, 1, negative 1 to 0. Maybe using something like sine function. Yeah, might be better. So this is the detail. And for the y value, I can use a sine function. Calculate the sine value, which goes from 0 to 1. I mean 0 to 1 to negative 1 to 0 by using 360 degrees from the first frame to the end frame, which will give you value between 0 minus 1 to 1. Not sure if the range is okay. Let's see. Then goes like this. Okay, seems like I still have some syntax error here. Unable to evaluate expressions. There are too many functions written here. Okay, so first this parenthesis, and you have frame adding by 20 multiplied by noise, and detail multiply by this one, adding by this one, and you cannot use parentheses here. Okay. Okay, I guess that's it. Nope. Still not. Okay, maybe I'm still missing something here. So noise, okay. I think I need one more parenthesis here. Alright. Okay, let's see. So now the curve offset is also shifting. Looks better. Better than using randomness. Okay. Yeah, I think that's cool. And maybe for each I mean, you could also change the speed here based on curve iterations, but maybe I'll just skip that. Okay, so I think this is good. I mean, if you want to change the speed, you could also multiply something like 0.1 to here. I think it will become a bit more slowly. Not sure. Gonna keep it as 1. Now, let's say I'm okay with this. Now, the last part will be to use these trails to create the animation which runs on top of each curve. Okay. Alan says I think it jumps from last to first frame with the noise. Is it? Let me check that, if that's the case. Well, I'm gonna try with the transform node. So it's easy to check. Okay. So let's see, let's change the Y value here. Using frame end. Okay. And 0, 0. So if 0 and 1 have the same value, then this will repeat continuously. It's a bit too slow. Oh, actually it did. Didn't know that. Oopsie. Says so. Noise calculated in unit, space, lattice, and then internal points interpolated to lattice points. It means noise will be independent between points, and you can scale infinite shapes for use. If that's the case, then I don't really need to use sine functions. Let's go back. Just remove this. So this should just be okay. Oh, I guess I also need to make these values the same to make it continuous. I think that's the case, isn't it? Yeah, there is some glitch here. If I make it to, I don't know, multiply by 0. If I make it the same value, yeah, for sure this will just be continuous. So seems like if I want to use the different value for the x or z or anything, I might need to still need to use sine functions for that, probably. Yeah, I guess. Okay, so that case, I'm gonna make this black. Sign. Oh, it's not really. It's not having a continuous anymore. What am I missing here? What did I do wrong? Wait. Let me see what I did previously. Yeah, I guess I probably need to make these value also changing in order to make it continuous. Not sure if that's the case. Wait a minute. Let me check what value am I getting here. Okay. Okay, let me check one by one. Oh, I'm having a negative value. That's why. So, seems like the noise function gives you a negative value as well. Didn't know that. Does it say so? It doesn't say here, but seems like it does. So, I need to gonna make sure that it also if it's negative, then goes back to the end frame as well. So in this case, in order to do that, you can just add additional end frame to this whole setup, and that should make everything always positive. Yeah, and that should create the loop continuous. And maybe for that I might not need to use sign function. No. Let me see. There's a slight change from the last frame to the end frame. Maybe if you still have different value for the x value, this might not just work. So maybe in the end, I'll go with this. Okay. At least for this one, just go smoothly connected from end to first. Alright, that's good. Alright, so let's do this with this. Now, as for the last setup, I want to run some thickened pipe running on top of each curve, right? And to do that, just gonna use a polywire attached to this curve, And I'm just going to change the thickness at each point to make it look like it's animating from start point to the end point. Okay. Make the divisions to some value here and accessing to a P scale, which I don't have it right now. So let's make this P scale value animated for each point and used as a thickness. Right. Point wrangle or primitive wrangle, whichever it is. And for, I think for each curve it's better to have, it's good to have a curve u value for each point, meaning if it's at the starting point, it's easier if you have a value equal to 0. If it's at the end point, if it's easier if you have a value equal to 1. So you can get that by going back to the last resample node, promoting curve u here. As a result, should be able to get, the point attribute called curve u on each point starting from 0 to 1 for each primitive, for each curve here. Right. And where am I right now? Okay. So now I can access to this curve u attribute and use this to define the thickness. Okay, so let's do that, and I want to animate it going from start to the top, start to the end, maybe using some wave function like sine wave to change the height or thickness of the curve, just like it moving from bottom to top. So I also need the frame base value together with some sine function. Okay, so let's first decide the maximum thickness of this, or the base thickness of this curve. And I'm gonna try applying this as a P scale to test one by one. So if I increase the base thickness, okay, I'm controlling the thickness of this each curve. Now since I'm dealing with the smoke, which probably it's thicker in the starting point and becomes thinner and thinner when it reaches to the end, I'm gonna create some want to make the thickness going thinner and thinner based on the curve u value. So that is, I'm gonna call it as T, or just gonna call it A, and use the fit function to convert the curve u, which is in this case from 0 to 1, and I want to flip it into 0 to 1 to 0. Then multiply this A with base thickness. You can control the thickness based on its distance from the point, the starting point. Okay, and if you want, you could also apply some power function to this to control how fast it becomes thinner or how slow it becomes thinner. Right. So let's give parameter for this one thin power. Going from 0 to 3 or 2. So 1 is default, 1 is the linear result, so I'm gonna start with 1. Okay, now let's apply some sine wave animation to change the thickness. What I want to do is to, based on some wave values, for some part I want to make the thickness to be 0 so that you cannot really see the pipe. Okay, so to do that, I guess you need to subtract some thickness made by sine wave to this original base thickness, or you just multiply the sine wave value to this base thickness by giving some 0 value to the sine based wavy value. So let's create the wave value based on the sine function. Curve view, change the curve view to the angle by multiplying this by pi multiply by 2, which will give you 360 degrees. If you if you want to have multiple number of waves, then you could also set the number of waves you want to give. And let's try with this one now. Okay, so this will give you a value in between -1 to +1 several times by increasing this one. If it's just 1, then you only have 1 +1 and 1 -1, single -1 and single +1. If you make it 2, the number of wave will be doubled. Now, next, what I want to do is to change this value so that I can multiply it to this base thickness to change its thickness. So I don't need the negative value. I want to make either 0 from 0 to 1. So let's refit it. Refit this value that I created to in between 0 to 1. Right. Now, if I multiply this with the current function, okay, well, it's not as I imagined. Maybe I need to increase a bit more random wave. So more wave you have, more thinner area you get, like these. Okay. Now I might want to have a bit more wider, thinner areas. So let's control that by introducing power functions to this one as well. If I make it 2, yeah, it becomes the empty area becomes wider. If you increase this more, it becomes wider and wider. Okay, becomes like starting to become like a whirlwind like shape. So maybe better to have this as a parameter. Let's call this wave power. Let's set the range from 0 to 5. Okay. Let's go with the initial value equal to 2. Okay. Now that it looks like it's starting to look like a part of the smoking stuff, next thing I want to do is to offset these area which the thickness is being determined. It's looks a bit too artificial where you have the same positions having the same thickness like these. So I want to shift those a little bit. It could be randomish, it could be based on the noise function. I'll try with the randomness, this one. Now to shift this, what you need to do is to change the the wave functions, the sine functions starting angle. Okay, so you could add additional angle, pi multiplied by 2 pi by some random value. Okay, and based on the random value could be based on the primitive number, I think. So the primitive number from this point could be point prims pt num 0. Okay, so just gonna try entering primitive number inside randomness and see what happens. So it's been shifted a little bit. Now you are seeing those continuous line, but you do have some disconnection between those lines at some point. And probably it's better to have some seed parameter for this one so that you can change the randomness. Maybe instead of using random, using noise function might be better again. Because randomness, if you just use randomness, it's a bit hard to control how much you want to shift, because it's just shift a lot. Or you could also control the angle here, how much you want to shift. This is the maximum value, maximum angle, how much you can shift with the random value. Maybe I can just parameterize this one instead. Maybe I can multiply some value here. Angle shift. So if it's 0, the thickness is at the same positions, and if I increase a little bit more, then start to shift a little bit more. Now this looks a bit more better, a bit more organic, right? Okay, now next thing I would like to do is to actually move this sine based thickness going from bottom to top. Okay, in order to do that, you need to introduce some frame-based value, frame-based angle to this sine parameter. So it's getting longer, so let's break down to a bit simple line. So first of all, this was for the base wave angle, so let's make it as a variable. wave base angle is this one, and this is a random shift. So bring this as another variable. So base angle plus shift angle, and the last angle you want to have is the animation angle. So let's call this anim angle, and that is going to be based on the frame. So frame, and I want to make it looped from first frame to the end frame. It has to be a multiplication of 2 pi if you want to use it inside a sine, because by the multiple number of 2 pi the sine wave gives you the same value from the start to end. So I am going to multiply the frame value, convert it into 0 to 1, normalize the frame value, then multiply it by pi by 2. And you could additionally multiply integers to this if you want to change the speed. So let's give an integer value called speed and add it to this one. Okay, let's make the speed to 1 for now, and let's see how it goes. If I play it, I am not sure if it's playing. If I increase this, nothing happens. Maybe I'm doing something wrong. I was hoping this thickness will change, but it's not, so I think I'm doing something wrong here. Okay, what did I do wrong? I realize I cannot use this one inside Vex Wrangle. I need to write the frame like this. Add frame. Okay, now it's going backward, going from top to bottom, so I think I need to make it negative. Like this. Okay, so now it's moving. It's a bit too slow. Let's make it faster. Alright. Starting to get some shift. There you go. Now it's getting somewhere, yes. Now I can tweak some of the parameters that I already have. For example, the spreadness of the first edge. I think I had some problem here. I need to fix this. It's the starting positions. Okay. And number of curves. Maybe you need to have at least 3 to have smooth transitions between the curve. Okay, and the number of offsets. No, this was not it. This was the detangle. The number of offset was this one. So if you only have one curve, it looks like this. And by controlling the wave number, you have less waves. Yeah. And having multiple number becomes a bit more organic. You can control how much you want to shift. If it's 10, all the curves becomes really close to each other. And you could also change the shift value here. Yeah, it's getting better. Oh, the randomness, wave power. Okay, yeah, I think I'm so far the parameter looks all good, so I guess it's time I organize these a little bit to make it a bit more accessible. Okay, so let's do that. First of all, there are some things that I need to check. When I make this number to 1, the height becomes a bit lower. Now why is that? If it's 0, that's not going to create any points, so that's fine. If it's equal to 1, the point's being created right here without an offset. Well, it did have an offset. If it's something look different here when it's equal to 1 or to more than 2. Okay, what's that? So okay, so if it's equal to 1, then this becomes 0, so that's the problem. Alright, so let's make this like this. Yeah, this will make sure that I always have at least 1 point here. Okay, it's better. Now, I'm gonna start by creating null node named controllers to collect all the parameters that I created, which is responsible for determining the final visual. Okay. First thing first, going back to the original, if you change the size of this cube, you could also change the size of this trail, so this will be important. Base trail size, or I should call this smoke, I guess. From 0 to 2. Next, volume is fine. The number of points, this is also important. If you have, not this one, if you have many number of points, the final curve will be really noisy, like this one. As a result, the final path you get is also becomes really noisy. In some case, this might be interesting. Yeah. In some case, not. If you have small number of points, you get more of a simplified trail animation. Okay, so this is important. How do I name this? Let's say from 1 to 100 small complexity. I don't know. Next, at node, this is automatic resample. You might be able to change this one to change the result. Larger value you have, more larger gestures you get. Let's see. If I have more points and if I increase the resample length, yeah, so this could change the result for sure. So yeah, this maybe some other important parameters. Let's just say smoke trail resolutions. Let's go from 0 to 1. Shouldn't be too big. Alright. What else? So you have smooth, that's automatic. Detangle, yeah, it's okay. Move to starting points, yeah. So this is also important. So this is the starting point parameter. So this is like a starting point straightness. More points you have, it's gonna be more straight. So start straightness. Let's go from 1 to 5. Next, y offset. So this is offset for the starting point. So let's just give a start offset. Okay. Next, smoothness, that's automatic. Point number. Resample. These are all automatic. Yep. You have another resample here. Probably I don't really need to change here. It's not really important. Make it primitive. Yep. Creating the curve. Yep. Connecting. Smoothing. Shifting. Yeah. So here you could change some parameters. This is the maximum value of time shift. So max time trail shift frame. It's not really straightforward. It's not really, might not really make sense, but let's say. And let's say from 0 to like 50. Now, going back, make it some value, copy this parameter and paste it here. Okay. Anything else? There is some seed value here. Used for a random seed or noise function. Maybe I can have that as a parameter as well. Let's make the range from 0 to 1000. And copy that value. Paste it here. Okay. Now, anything else? Nope. Okay, finally this one is you have a bunch of parameters here. The base thickness, that's for the smoke. So smoke thickness. The thin power. Smoke. How do I call this? Thinning power. The wave number. Smoke wave number. Wave power. Smoke wave power. Seed. So you already have a seed, so I can just copy that. I have already created the seed here, so I can just pass that to the seed value. The angle shift. That's for the, again, the smoke angle shift. I'm gonna make it from 0 to 2. And finally the speed. Smoke animating speed. Which is an integer. Alright. So I guess that's about it. Let's see. Let's see if I can control the smoke playing it. So this is the base size. Yep. And the complexity will add several points to make it more complex. If you increase the trail resolutions, you are going to have higher collision detection in terms of the distance, making the curve wider. A little bit weird on the end though. I might want to trim those end points. Looks a bit weird. Let's do that. Anything else? The start straightness. If you make it 1, it's going to have more angle. Yeah. More points you have, it's gonna be more straight. Okay. Start offset, that's just the distance. Doesn't really look natural if it's too long. Okay, now the maximum trail shift frame, that's how much each offsetted curve have some time shift, maximum time shift. This will look good. And the random seed just changes the randomness, and some smoke thickness, the base thickness of the smoke. Then you have a thinning power. Controlling how strong the thinning from start to end gives. And the smoke wave number. I guess if you have a longer curve, you might want to have multiple number of waves. I guess it really depends on the length of the total curve. In smoke wave power, it just controls how the thinner part, how wide the thinner part is. Yeah. And the smoke angle shift, that's how where you control how randomly shift each curve in a animating direction, and this is speed. All right. Okay. Not bad. Yeah, not that bad, I guess. So one thing I want to do, I want to have as an additional control, is to trim the end points a little bit, like these one. So where should I do that? I could go back to where I set the thickness, I guess. Yeah, right here. So probably I could introduce some maximum U value that I'm going to use here. So trim U. Okay, so this will trim the curve based on these percentage. So if I just want to use 80% of the whole curve, I just say 80.8. And that looks a bit more natural to me. Right. Okay. Hello, vision of Jeremiah. Thank you. Okay, now it looks good. It's time. I am composing all the stuff with some characters to make it look like it's a smoke out of some cigarette. Right. By the way, I myself don't smoke at all. So first I'm going to place this so that the starting point will come to the 0, 0, 0 positions by, maybe I can offset it using the parameter I already have here. One is this size of the uni scale. Multiplied by 0.5. Oops. And adding the y offset value, which is this one. So that is negative this value here, which will reset, move the whole smoke to stand on 0, 0, 0 positions. Okay, now if you want to make it like a cartoonish look, you can just choose the shader to hide the shadows like that. And brighten up a little bit. To make it look like a bit more like a smoke or stylized smoke. Well, I'm not sure if you can really call it as a smoke, but at least looks something. Looks like some kind of wind-based trail, something. It's not really, as you can see, it's not really based on any physical properties, so it's just procedural, random procedural stuff. So I hope you take it as some random procedural technique, not as a real like smoke simulations. Okay. Well, there are a bunch of parameters I already have, and I am starting to forget what does what. So this was the frame shift. Could even be interesting if I shift it really high. Yeah, this is also interesting. Let me just raise the shift, time shift value. What was it? This one. To 200. Now this is no more like a cigarette smoke, but something else. Not sure what this is. Okay. Well, where was I? So I wanted to add some tubes to make it look like a cigarette, just for fun. Merge it together with now this part is totally manual. And let pig smoke. This pig is having all sorts of experiment from a mad scientist. There you go. Right, so that's it. This is it for today. try to create kind of a smoke-like simulations or smoke-like setup, procedural setup, and not by using a physical properties but just using procedural setup. And not sure how it is useful for anything, but as a technique, some of the part could be interesting, could be useful for some other usage. So I hope you found it somehow useful in some case, at some point. If that's so, that would be great. Let me know if you have any questions to this one. If not, I'll end the live stream here. Thank you, Vox Mega. Hello, Dream Team. Well, yeah, at least I enjoyed creating this. I just want to say I'm not proposing to smoke. I mean, I just wanted to make the visual, that's it. Yeah. Like the visual. Totally forgot where I was controlling the number of this one. Number of smokes. Oh, actually, I didn't have this parameter. Let's have that as well. As a final parameter. Okay, from 1 to 10. There you go. Heavy smoking pighead. Alright, that's it. Box mega smoke starting point. Need to adjust the size to fit the cigarette light. Sure, yes. Yeah. Yeah, I'm doing this all manually for the cigarette thing here. So maybe I can adjust the thickness of the cigarette based on the smoke that I have here, which is this one. Copy it, paste it right here. Multiply by 2 or something, or a bit more thicker. Now it looks more like a cigar. Okay, well, it's just the side stuff. Okay, well, thank you for everything. I mean, thank you for all the comments and watching. I would like to end here. And as always, I'm going to upload the files to a page. I'm going to paste the URL where you can download the hip file to this video description page of this YouTube live stream, and which is going to be a Patreon page, but you can access it for free. But if you are kind enough to support me on Patreon, then that will be awesome as well. Yeah, that's it. Thank you and see you. That's it for today.